All right, class, in this video, we want to work through congruence and transformations. Now, congruence relates to two figures being the same size. So it differs from similarity. Similarity, we can have two figures that have common ratios, meaning like one side might be 3 and the other side might be 6, and there's a scale factor of 2. But in this case, with congruence, we're wanting them to be the actual same size. So in this case, if we look at this first example, are the two figures congruent? And by two figures, we're referring to triangle ABC and XYZ. And so one of the ways we can look at these and say, all right, well, AB is 2, XY, which is a corresponding part, that is 2 as well. So if we were to compare, if we were just to say AB, name these, and I've talked about that in another video, I'm just naming my figures and I'm defining here, I'm defining my direction. I could say line segment AB to line segment XY, that's 2 over 2, all right, that equals 1. I could look at BC and I can count up that it's 3 and ZY is also 3. And when I compare BC to ZY, I would get 3 over 3. Or 1. And so I'm seeing that these shapes are the exact same size. When I see the 3 over 3 equals 1, when I see these two be the exact same, yes, I'm seeing similarity, but notice here, I'm also seeing the side lengths are the exact same. There is congruence. Now, we want to think about this in the context of transformations. Is triangle ABC congruent? Yes, it is. How can we transform it and to overlay XYZ with ABC? What I want you to see is that if I reflect ABC across the y-axis, then I have C prime is there. Why don't we write that? That's C prime, B prime, and A prime. Now, I'm not going to walk through that process because we did that in previous videos under transformations. But then I see that these line up. Look at these points. They all line up. So now, not only am I going to do, my first step would be a transformation, a reflection, I should say, across the y-axis. Then I'm going to translate it up. 1, 2, 3, 4 units up. So if I translate 4 units up, I will overlay triangle ABC on top of XYZ. So it's a two-step process there. It's a reflection across the y-axis and a translation of up of 2 units. So I want you to pause the video and look at the practice problem. First, are they congruent? If they are, how can I map ABCD on top of WXYZ? All right, well, hopefully you've paused the video and you start assessing these. I see BC is 2, and that's going to correspond to XY. DC is 2. XW here is also 2. But now look at YZ and AB. That's 3, but YZ is 4. And as soon as I begin to see that, and you can actually tell by looking at it, this one is longer horizontally. It's stretched. So these triangles are not congruent. And it really is just as straightforward as counting up those side lengths and considering those ratios. Notice that I didn't write down a lot of ratios because I can see that there's congruence happening here until it doesn't. And the first time it doesn't, those two shapes are not congruent. Let's look at a couple of examples, and one more example in a practice problem. Are the two figures congruent? Going to be the same process here. AB is 3, CB is 2. Now XY is going to correspond to CB, and those are 2. And I could even show a little tick mark here saying those are the same. But YZ is 4. And so I have a point of non-congruence here. AB corresponds to YZ, but they are not the same length. These are not congruent, nor are they similar. If I were to compare, let's say YZ to AB, I'm going to get 4/3, but if I compared XY to BC, I'm going to get 2 over 2, which is 1. 4/3 does not equal 1, nor are these similar. They're not congruent. They're not similar. And so let's go ahead and check this other practice problem. I'm going to go ahead and label these, and then I would encourage you to, all right, if you saw that, that means I hit the zoom button and it went crazy. And so I've just backed up just a little bit here. And let's just say W, X, Y, Z. And let's begin to check these. DC is 2, CD is 3, AD is 3. I'm not worried about this slant right now. I'm going to see if I can determine congruency elsewhere. I see WZ is 2, WX is 3, and XY is 4. And now all of a sudden it's beginning to show up. 2 and 2. I have corresponding parts. There's a 90 degree, there's a 90 degree. Those 3s, those are going to be corresponding parts. But look, AD and XY, those are not the same. 3 does not equal 4. Therefore, they are not congruent. These shapes are not congruent, so there's not going to be a way for me to transform one shape onto the other. So just remember the difference between congruence and similarity. Similarity, same shape, same ratios, but not the same side lengths. They will be different. Congruent, they are the same shape, they are the same size. So not only are they similar, but they are also congruent in that way. The side lengths will be the same as well. Guys, I hope this is basic. I hope it helps. There's definitely more to do with this subject, but hopefully this helps get you started. Send me questions if you got them.